Hi guys.
Hey guys.
Hey guys, how are you liking college so far?
I love it.
It's great.
I don't know. I've noticed that the stress of college has caused me to be eating a lot. I don't think the freshman 15 was a myth after all.
I think it is a myth. Everyone has the choice to eat healthy.
I don't think it's a myth. That's why before every class I grab a yogurt. Always strawberry though, because I do believe that vanilla and strawberry yogurt have a calorie difference.
I don't know. Settle down, guys. We'll figure this out with the students' team model to figure out the mean weight gain of college students and the calorie difference in strawberry and vanilla yogurt.
Wow. Cornell professor of nutrition David Levitsky recruited students from two large sections of an introductory health course. Although they were volunteers, they appeared to match the rest of the freshman class in terms of demographic variables such as sex and ethnicity. The students were weighed during the first week of the semester and then 12 weeks later. Based on Professor Levitsky's data, estimate the mean weight gain in first semester freshmen and comment on the freshman 15.
So the problem shows us that the data is paired by students. So this is our first condition, and we're just going to write data is paired by students. In the problem, it says that even though the students were volunteers, the freshmen from both sections are representative of their freshman class. So that's what we're going to write out to fulfill the random condition. Next, we're going to check the 10% condition, which ensures that the sample is less than 10% of the entire population. Since the sample is 68 students and 68 times 10 is 680, it's reasonable to believe that there are at least 680 students in the introductory health class at Cornell University. Now we're going to check the nearly normal condition. So let's go to the calculator.
Okay, to check the nearly normal condition, you're going to go to second y equals to check the normal probability plot. Press enter on plot 1, scroll to the last graph and press enter. Our data is in L3, so that stays the same, and then you're going to press zoom 9 to see the normal probability plot. So now that the normal probability plot is in the calculator, you want to sketch the graph, and because the normal probability plot for the difference between initial and final weight is fairly linear and all other conditions are met,
we will proceed with an approximately normal model and a student's paired t-interval with the degrees of freedom of 67.
So to do the t-interval, you're going to go to Stat, Edit, enter the data into L1 and L2. For L3, highlight it, and then go to second L2 minus second L1 to get the differences in weight, initial and final. Then go to Stat, Tests, scroll down to t-interval, data. Our data is in L3 and it's a 95% confidence interval. Calculate, and you get the t-interval and other variables. Okay, so to run the test, you're going to first write out the formula, which is d bar, the mean difference, plus or minus critical t with degrees of freedom 67, times the sample standard deviation over the square root of n, which is the sample size. So you're going to fill in the values that you got from the calculator, which the mean is 1.91176, plus or minus the critical t, which ends up being 1.996, times 2.12824, which is the sample standard deviation, over the square root of 68, which is the sample size. To get the critical t, in the calculator you do second vars, inverse t, an area of 0.025 since it's 95% confident, and then degrees of freedom of 67. So when all of this data is entered in the calculator, it tells us that the confidence interval is 1.3966 to 2.4269.
We are 95% confident that the freshmen at Cornell's introductory health class have a mean weight gain average between 1.3966 and 2.426 pounds during the first 12 weeks of college. Okay guys, now that we're 95% sure that the first year freshmen gain about a mean difference of 1.4 to 2.4 pounds, let's see if there's actually a difference in the calorie content of the strawberry yogurt I eat and vanilla yogurt with the t-test.
Let's check the conditions first.
Is there a significant difference in calories between servings of strawberry and vanilla yogurt? Based on the data shown in the table, test an appropriate hypothesis and state your conclusion. Don't forget to check the assumptions and conditions.
Okay, so we're going to start by doing the hypotheses. So the null hypothesis is that nothing is different. So the mean difference between calories in servings of strawberry yogurt and calories in servings of vanilla yogurt is 0. And the alternate hypothesis would be that the mean difference is not 0. Now, when you're doing these problems, you also have to define what D is. So D is the calories in serving strawberry minus calories in servings vanilla.
The first condition we're going to check is the paired assumption. In this question, the yogurt is paired by brand. The second condition we're going to check is the random condition. It is reasonable to believe that the brands selected in this problem are representative of all strawberry and vanilla yogurt brands. The third condition we're going to check is the 10% condition. Since we have a sample size of 12, we're going to multiply that by 10. 12 times 10 is 120. We are looking to see if 120 is 10% of the population. But since 120, there may not be at least 120 yogurt brands, we will proceed with caution. The last condition we're going to check is a nearly normal condition. We are going to start this condition by creating a nearly normal plot in the calculator.
Okay, to check the nearly normal condition, you're going to want to check the normal probability plot. So you're going to go to second y equals plot on. You're going to highlight the last plot, this one. Your data should already be in L3 for the difference. Then you're going to go to zoom 9 to see your plot.
After getting the nearly probability plot from the calculator, we're going to sketch it out on our paper. Because the normal probability plot of the difference between calories of strawberry and vanilla yogurt is fairly linear, though there seems to be a slight outlier and all the other conditions are met, we will proceed with caution with an approximately normal and pair t-test for means with a degrees of freedom of 11.
To run the t-test, you're going to go to Stat, Edit, enter your data in L1 and L2 for the strawberry and vanilla calories, highlight L3, and go to second L1 minus second L2 to get the difference between the calorie count. Then you go to Stat, scroll over to Test, t-test. You highlight data because it's in the list. The difference is in L3, and it's a not equal to. Then you go to calculate, and you get your t-score and your p-value. So to set up our formula and our calculation, you're going to do t sub 11, since the degrees of freedom are 11, equals d bar, which is the mean difference, minus 0, over the sample standard deviation over the square root of n, the sample size. When you plug in the numbers, you get t sub 11 equals 12.5 minus 0 over 32.509 divided by square root of 12. So now we're going to draw our approximately normal distribution, and it's a two-tailed test, so we're going to shade both sides at t equals negative 1.332 and t equals positive 1.32. So the p-value of this area is 0.2098, so we're going to draw an arrow to both sides and write the p-value.
With a p-value of 0.2098, which is higher than an alpha level of 0.05, we will fail to reject the null hypothesis. There is insufficient evidence to suggest that the mean calorie content in strawberry and vanilla yogurt are different. Alright guys, so I guess I wasn't right about the difference in calorie content, but I'm still going to eat strawberry yogurt and steal it from the cafeteria.
Yeah, I guess the freshman 15 is a little bit exaggerated, so let's just work hard and have fun in college.
Alright, now I want some yogurt. Same.
Strawberry too!
Yay!